Okay, there's typically in most math books describe this criteria as 5. And I've developed a good little memory mnemonic, which I'll show you in a sec, for remembering these 5 criteria. So there's just 4 and a cool way to remember them. First off, when you look at an equation, in a quadratic equation, ax squared plus bx plus c, you can extract details of what the graph will look like when you sketch that equation based on these 5 things. And then you can, from these 5 things, graph that equation with incredible amount of accuracy. First one is concavity. And I'll do a segment on all of these so that you'll understand them in detail. But just kind of like survey of all these 5 things is concavity. Is the graph concave up or is it concave down? And you'll see what that means in a second, but that's one thing you can extract from the graph just by looking at the A values, positive or negative. You'll understand that in a sec. Concavity. Second one is X-intercepts. Where does the graph hit the X-axis? So here, it's always going to be X value 0, and X value 0, because Y is going to be always 0 when the graph touches the X-axis. And that's useful information for sketching the graph accurately. Then we've got the Y-intercept, where the graph has a 0 value of X, and it only touches the Y-axis. And then there's the maximum or minimum coordinates, depending on if the graph is concave up. If it's concave up, it'll have the minimum, the lowest value, the lowest coordinate of the graph. If the graph is concave down, the graph will have a maximum value. You can learn the maximum and minimum value coordinates just by looking at the equation and doing a tiny bit of arithmetic math. And then you can get that maximum value or that minimum value, depending on the shape of the graph. And finally, the axis of symmetry, which to me isn't that helpful, but it is kind of cool to know. It just, because the axis of symmetry is almost identical to the maximum minimum value, but it's, if you were to fold the graph along a vertical axis, what would that axis be so that each side would match up. So that's about it for all the criteria. Here's the mnemonic for remembering that I devised. I think is quite clever. It's called lighting is a huge problem, enormous problem. I don't like these technical cinematographical details of lighting. Anyways, it's SEMA, concavity, concave up or down. Intercepts. You don't look at this X-intercept and Y-intercept, just clump the intercepts together and then know that then you can learn the X and the Y-intercepts. And then maximum, minimum, and then finally the axis of symmetry. So CIMA. That can help you remember the criteria, the information that you can extract from an equation to then graph it. It's concavity C, intercepts X and Y, I. Maximum, minimum, M, and then axis of symmetry, A. So that's a cool way to remember that stuff. And now I'll get into the details of concavity, intercepts X and Y, maximum and minimum, and the axis of symmetry. Great, what is this?